All right, here we have 8.7, which describes modeling motion using parametric equations. So our objectives, model the motion using parametric equations and then use those equations to determine the motion of the projectile, namely its trajectory and its range. So, just a couple definitions. So projectile is anything object that launched. The trajectory is the path that it follows, and the range is the horizontal distance that it travels. So you can use parametric equations to represent the position in terms of the parameter t, which is why I use t typically as the parameter. So when you're finding parametric equations, you need to find the horizontal, which is Vx, and vertical components of the initial velocity. So these equations you've seen before. So the horizontal is the magnitude times the cosine of the angle. The vertical is the magnitude times the sine of the angle. So here's your two equations. So if a projectile is launched at some angle theta with the horizontal, so relative to the ground, with initial velocity v, the path of the projectile is described by these equations. So t is time, g is the acceleration due to gravity, which depending on your units you'll use either negative 32 feet per second squared or negative 9.8 meters per second squared. If your units are metric units, you use this one. If they're English units, you use that one. So the horizontal position is t times, so t is time times the horizontal component. The vertical position is this equation. So, example 1 here. Suppose a professional football player kicks a football with initial velocity of 29 yards per second at an angle of 68 degrees to the horizontal. Suppose a kick returner catches the ball 5 seconds later. How far has the ball traveled horizontally? And what is its vertical height at the time? So we have two equations. You have this one, x equals t v cos theta, and y equals t plus 1/2 gt squared plus h. Now this h term is the starting height. So horizontally is in the x direction. So we're going to use the x equation. So x is going to equal t is 5. The magnitude is 29 yards per second, but I need that in feet per second, so I need to multiply by 3, which gives me 87. And then the cosine of my angle is 68 degrees. So 5 times 87 times the cosine of 68. So that is 162, we'll call it 63 feet. I'm going to convert my units to feet here. So y is going to equal 5, the time. Oops. V is 87. The sine of 68 degrees plus 1/2. Since I'm in English units, g is negative 32. 5 squared plus, just kicked from the ground, so h is 0. So 5 times 87 times the sine of 68 plus 0.5 times negative 32 times 5 squared plus 0. So y equals 3.3 feet. So it's traveled 163 feet, which is about 54 yards, and it's going to be caught 3 feet above the ground. Alright, so for example 2, Amy Kyler led the National Pro Fast Pitch Women's Softball League in strikeouts in 03. Suppose she throws the ball at an angle of 5.2 at the horizontal at a speed of 67 miles per hour. The distance from the pitcher's mound to home plate is 43 feet. If Amy releases the ball 2.7 feet above the ground, how far above the ground is the ball when it crosses home plate? So if you notice, they don't give you any times, so you're going to have to figure out what that is. You can do that because you know the horizontal distance. So this equation, x equals t v cos theta, we can solve that one because we know everything on the right hand side. We know the angle, the starting speed, and we know this x value. We can solve for t. Now I'm going to turn 67 miles per hour into feet per second. So I need my units to be in feet in second. So there are 5,702. I don't remember how many feet are in a mile. Well, this way. In 1 hour there are 3,600 feet. 5,280. Yeah, 5,280 feet in 1 mile. So 67 times 5280 divided by 3600. So that is, V is equal to 98.3 feet per second. So x is 43, it travels 43 feet. I don't know t. V is that 98.3, and the cosine of 5.2. So 98.3 times the cosine of 5.2. So 43 equals 97.9 t. Then divide both sides by 97.9. Gives me t is equal to 4.44 seconds. So now I can use my y equation. Y equals tv sine theta plus 1/2 gt squared plus h. So t is 0.44, v is 98.3, sine of 5.2 plus 1/2, since I'm in feet, it's negative 32.44 squared, and then h is 2.7. So 0.44 times 98.3 times the sine of 5.2 plus 0.5 times negative 32 times 0.44 squared plus 2.7. So y equals 3.6 feet. So when it crosses home plate, it's 3.6 feet above the ground. So that's the end of 8.7.